Hi, it's Salem Straub here at Promethean Knives. I'm working on something I find kind of interesting today, so doing a little video to kind of talk about that a little bit. I'm going to be using my twisting machine that I made. It's a three-phase variable speed reversible electric mechanical twister, and it greatly speeds up and eases the production of twisted bars for different types of Damascus steel. So I'm going to bring the camera up close and kind of go over the machine, and then I'll actually do some of the hot work and you can kind of see how it works. So let's get into it. So this is the end grain of the bar that I'm going to be twisting. It's a parquet twist, so this is basically like just a four-way, like you'd start a basket weave. Makes your twist more interesting. And it's at about 3/4 square right now with the edges knocked down. I got two bars like that. I'm going to twist one right hand, one left hand. And this is what we are going to use. This is the overall machine. It's got a bed kind of like a lathe, just fabbed out of some rusty square tube. Pipe legs. Direct drive here. This is a 1/2 horsepower 3-phase gear motor that I found locally, just laying around, happened to work. It's got a very slow output. It'll get me up to about 80 RPM with the VFD all the way turned up, which is a pretty good top speed for twisting. And here I've just welded basically an adjustable square collet made out of grade 8 bolts and nuts, welded to square tube, welded to this cog. So I can get anything from about a 3/8 square to a 1.25 inch square bar in there. That slides along the bed. It has to slide a little bit because the bar will shorten when you're twisting it. It can clamp, but I don't often clamp it. Here is the tailstock end. And you can make it to where a bar will pass through, so if you wanted to do some different twist features on different parts of a bar, but so far I've just been using it for twisting whole bars the same direction. Now, what I've done here for a foot switch is I ran the 3-phase into this box, and it is a 3-phase knife switch, so 3-pole, and it's made to be mounted on the wall and used by hand, but you can step on this switch real handy, so it kind of worked out perfect for this use. Anyway, now that I've got my cold bars here set in there into the collet and adjusted to both of them, basically to be a slightly loose fit so that, you know, the bar is a little bigger when it's hotter. This is a little bit far off so that I can slip it in that end fine when it's hot and then just bring this end up real quick. This is already set to the bar. You know, if I can do that without fumbling it, which gets easier with practice, then you can get a real good twist pretty quick. And then over here I've got a pipe wrench if I need it, and some bar holding tongs with notches just for stopping the bar from twisting if I want to. So let's fire up the forge and have at it. So this is my ribbon burner forge. I built it pretty recently. It looks kind of just like a pile of bricks, but that's because I have recycled a bunch of old kiln bricks from an electric pottery kiln that I got. The lid, as you can see, is the base of this forge. It provides a nice wide floor. And looking in the door there, you can see my cast ribbon burner. It's got, gosh, how many? 29 orifices, as I recall, cast with birthday crayons and refractory. You can see it puts out a brushy multiple flame there, which burns the propane quite cleanly and completely. So it's a very good fire for pattern welding in, for instance, since you can really dial it in to not scale the steel up at all. I like it for this twisting because it's got a floor, unlike my vertical forge, so I can just set the bars right in there and get a nice even heat on them. So with the bar hot, we come right over to the twisting rig and fight it in there and scoot the tailstock up, snug it a little bit, step on the pedal here, and away we go. You can see me tapping the tailstock along a little bit because it wants to bind. Later I really have to kind of improve this rig and maybe put it on a bearing slide so there's negligible friction and it just travels right along. So I just unwind the gearbox a little bit, pull the tailstock out. Now I got a bar twisted up pretty tight on one end, then I'll reheat it with a preference for the end that's not as tightly twisted. I'm doing the other bar now. I've reversed the machine. I'm twisting this one counterclockwise because one bar's clockwise, one's counter. So now I got both bars partially twisted. You can see how one end's pretty tight and the other end's still a little loose. Now we're putting the first bar back in and we're twisting the less twisted end up tighter. We've switched the machine back around to clockwise. But it really sucks if you forget to switch the machine and then you start untwisting your bar super rapidly. But as long as you get your head screwed on straight and you're thinking about what you're doing, you don't usually do that. So this is the second heat for the second bar. And this one is counterclockwise again, tapping the tailstock over. And we got the untwisted end hotter and up toward the tailstock, so it's being twisted tighter. And that one came out nice. You can get a super tight rate of twist with this thing, actually too tight for some patterns, so you have to watch it. So the next step is we brush the bars off, reheated them, and we're going to square them on the Beaudry. We're going to hammer that round twisted surface back to a nice square, and I do this at a welding heat, so it kind of heals the surface of the bar as much as possible. I used to do it with flux. Now I don't even bother to flux it. I just get it hot in that carburizing fire and smack it square. And since I'm doing a 2-bar weld here, ultimately they'll need to be about the same finish thickness as each other, so they'll mate up well for the final forge weld. Zooming in here for the second bar, I'm going to get a nice close-up of actual speed, how it happens on the die. You can see it turning square. Kind of tilt it back and forth. The big hammer is great for this because it covers so much real estate in one whack. And it really knocks the scale off better than a press does. A press just kind of, well, presses it into the surface. This time when we forge it square, we don't have to knock the corners down because it's not going to get twisted anymore. They're just going to get ground with forge welding. Now here, I think what I did was I had the forge hot, and while I was twisting, I decided to just throw another billet in there for another project to use that forge heat up while I had it. So you get a bonus in this video of smacking together a 13-layer billet in one heat and drawing it out, ready for cutting up again and restacking. The Beaudry is real good at this. As you watch this, you can see every time I flip the bar 90 and go back over it hard, it brightens it back up again from the friction heat of the sheer force of the hammer heats the steel back up. So this is all one heat. That's really quite good for a billet that size, to get it to restackable in one heat. And nice and flat. Easy to grind, easy to restack. Here's my son. He was outside watching. He likes to go boom, boom, and point at the big hammer. Name's Fire. And here is how those twisted bars ended up looking. Pretty even, pretty sharp and square. About the same height. We'll chop the ends off, and then we are going to weld them together in a pair. One's left and one's right, and they will become a sword and maybe another blade or two after that.